welcome. This is Algebra 2, Unit 3, or 7.3. How do you prove properties of logarithms? You guys are getting really good with the logarithms, so I just want to move right on into the properties. They should all make sense when we think about exponents. So the first property is log of b, log base b, to the b of the m would equal m. And if you think about that with numbers, all you're saying is log base 2, 8, equals log 2 of 2 to the third, because 8 is 2 raised to the third power. And when you're looking at this, you're just asking, to what power is 2 raised to equal 8? So that's why 2 base 2 and then 2 to the third would equal 3. Okay, it's a little bit confusing to try to put into words, but I think that you can see it there, where this base would cancel out that base of that exponent, and you would end up with 3. Next one, if you have any log, any base to the 1, you know that it's 0, because anything raised to the first power, anything raised to the 0th power equals 1. Okay, so that's why that would equal 0. Okay, no matter what the base is, if it's got a 1 there, it's going to be equal to 0. Now, any base to that base equals 1, because you're saying 2 to what power equals 2? It's going to be 1. 1. Okay? Another way you could look at this is it's just like this one up here. It's just raised to the first power at the base, and the base of that exponent cancels, and you get the 3. Okay? Next one, we look at product property of logs. What's really cool here is just think about your exponential properties that you've known since Algebra 1. When you add a to the m times a to the n, you added those exponents, right? Add the logs. Okay? Logs added together with the same base are the same thing as if you multiplied those two numbers. Okay? Now, quotient property, same thing. Think of your exponents, a to the m divided by a to the n. Same base, you just subtracted m minus n. So in logs, if you have log bm minus log bn, same bases, you can take those numbers and just divide them. Okay? Power property, same thing over here. When you had a to the m raised to the n, it was a to the m times n. Same thing here with logs. If you have a number out in front of the log, you can just take that log value and raise it to the n. Okay? Change of base. This is really handy for using calculators. If you have log, let's pretend it's log 2 equals 8, log base 2, 8, you can actually change their base in a calculator. Try this. Put in log, and I always remember the direction to go with this. The bigger number goes on top. Log 8 over log 2, the base number goes on the bottom. And now you've converted them to base 10, so you can put them in a calculator. Just put in log 8 over log, or divide by log 2, and you will end up getting 3, which is our answer to that. Anytime you have a log this way and you need to get it in a calculator, just convert it with the bigger one on top, the base one on the bottom, and it'll convert to base 10. It's really handy to have. Okay, so here we go. We have log 4, 4 to the 8th. Well, again, the base here and that base will cancel out. That equals 8. Okay, now we have a subtraction here. Remember from our properties, subtraction was divide, so this is equal to log 2, 28 divided by 7, which is equal to log 2, 4, which equals 2. Okay? Practice these a lot. The more you practice, the better it gets. It's just like thinking inversely in your brain. Okay, we have a plus here. That means that we can multiply. So log, there's no base, so we know it's a base 10. 40 times 25 would be 1,000. 10 raised to the third power equals 1,000. Okay, that's the end of this little lesson. I hope that those made sense. Review them in your notes, and then come into class ready to ask questions and do problems, practice problems.